first, you will have hopefully successfully done the background for this on your homework, so I can just focus on the new part, not the algebra. But here we go. Whether you know it or not, a couple of homework problems per set have been preparing you for today, Cramer's rule. So it goes like this. It's meant to solve a system of equations and do it instead of substitution or elimination. And remember, when you solve a system of equations, you're finding intersection points. And you might say, if I already have substitution, I have elimination, why do I need another way? Because this actually is the most applicable to technology. If you have a computer or a calculator that can solve matrices, then this is actually how you do an applied stat or multiple linear regression problem later on. So my point though is this. If you would, given the system, ax plus by equals c, equals e, and cx plus dy equals f, ax plus by equals e, cx plus dy equals f, if I asked you to solve for x and y. You've been doing that, right, lately, yes? So if I solve for x, then I want to eliminate y. How do you want to eliminate y? Okay, 1 by d and 1 by negative b. All right. So if I multiply 1 by d and the other by negative b, then my new system is a dx plus b dy equals bd, and the second is negative bc or cbx, whatever you like, minus bdy equals negative fb. Right? So then if I add straight down, I get a dx minus cbx, the y's go away, and I get ed minus fb. All right. If I then extract the x, then x is factored out, and I get x is ed minus fb over AD minus BC, or CB, whatever you want. With me? Okay, as in BC calculus, exactly. All right. Wow. So, looking for a pattern. My point, and the point of Cramer's rule is to say, you know what? I'm sick of doing these solving a system problems. There's got to be a quicker, better way. And there is. This guy, AD minus BC. Look back at the original problem. Where did AD minus BC come from? Minus. Doesn't AD minus BC come from down to the right minus up to the right? Yeah? So it seems like this looks like the determinant of the coefficients when I do matrices, yeah? Now the top one, that takes a little more vision on your part. ED minus BF. So it's like if you use these and you used these, but you didn't use those. Do you agree? It's got E's and B's and D's and F's in it, but not A's and C's. You follow? And so it's like if you took this e to the f and put it in those places, then wouldn't it be ed minus fb? In other words, this comes from if you put the constants in x's place, then you did the determinant. Now that is really Cramer's rule. The idea that, I can solve a system by, forget all this x and y. I don't need to, the x's and y's aren't important. What's important for one problem is what are the numbers in this problem. So it's the idea that forget the x's and y's. I'm just going to focus on what are all the coefficients because that's where it's coming from. Now, that said then, when we find, let's say, we want to use this idea to find f, or to find y rather, without all the elimination. And we said that the bottom over here, that the bottom of our answer came from taking the determinant of the coefficients. So couldn't I have found y by saying, forget all this elimination stuff, I just want to focus on the matrix A, B, C, D. Because that's what happened in x. The bottom of the fraction was just the determinant of the coefficients. You follow? And so when I go to evaluate that, that would be AD minus CB. Now the top was the one that was a little more complicated. Remember, the top came from taking this E and F and placing it in place of the x coefficients. But that's what we did to find x. To find y, we'll probably want to take the E and F and put them in place of the y coefficients. So in y, I'm going to keep AC, that column, but in place of the y coefficients, I'm going to replace those with, I'm going to put EF in those guys' places, so there's an EF here. Follow? What's the determinant? AF minus CE. That's Cramer's rule. The idea of using matrices to solve a system, and if you're good at it, it actually is quicker than substitution or elimination. Now, just in terms of the general rule here, the denominator determinants are the coefficients of the variables. The x coefficients and the y coefficients. No changes. The numerator determinants are the same coefficients, except the values of the variable for which you're solving are replaced by the values of the constants. So when I solve for y, I replaced y's column with the constants over here. When I solve for x, I replaced x's values with the constant over here. So here's what a problem will look like. Okay? Example 1. See where I'm at? Okay, so we're going to use this Cramer's rule idea to solve the system. X then is 2 determinants in fraction form. The lower determinant's the easier one. How do you read the matrix? When you read, you typically read across in a matrix. So what's the determinant in the bottom? 3, 2, 4, negative 3. Make sure you look at the sign in front too, not just the number. You follow me?
Yeah.
Okay? Devin, you with me? Excellent. All right. So in the top, if you're looking for x, then you replace x with the constants over here. So in the x column, which is the first column, I'm going to replace those with negative 1 and 10. The y coefficients don't get changed. They stay the same, so they are still 2 and negative 3. After that, I use my down to the right minus up to the right. What's down to the right minus up to the right in the top? 3 minus 20. And the denominator? Negative 9 minus 8. So did I get something like negative 17 over negative 17 or positive 1? Now that is the intersection point x. That's the x of the meeting point. Now let's find the y. The y. Again, a matrix over a matrix. What's in the denominator? 3, 2, 4, negative 3. Because it's the same, I already know what that denominator should come out to be. What should it come out to be? Negative 17, right? The numerator is going to be different. So what column stays, what column changes? Negative 110 goes in for the y column, and the x column will stay what it used to be, 3 and 4. So in place of, if we want y, you replace y. Get the constants over here, negative 110. So what's the determinant in the numerator? Down to the right minus up to the right is 30 minus 4, negative 4. Minus negative 4, so plus 4. I get 34 over negative 17, which is positive or negative? Negative 2. Therefore, these meet at negative 2, 1. Okay? All right. Now, sometimes it's the case that it's not what you would call in the proper form. The whole idea is it has to be in the correct x's and y's on one side in order and constants on the other. So this you would start by rewriting 2x plus 3y equals 7 and negative x plus y equals 9. Once you have it set up correctly, then you can use Cramer's rule. X is, please don't just write floating calculations. Please actually label, hey, this is X. I'm finding it here. So what's the bottom determinant? Sims, what's the bottom, it's not the determinant, what's the bottom matrix, please? Reading sideways.
2 negative, or across.
Across.
3
Yep.
negative 1.
I agree. And in the denominator, in the numerator, Kariana, which column do I replace, the x column or the y column? The x column. So the x column, instead of going to negative 1, will be replaced with 7, 9. The y column stays the same, so what's in the y column? 3, 1. Okay, now I evaluate. Down to the right minus up to the right is 7 minus 27. So I'm getting negative 20 in the numerator. What about the denominator? 2 minus negative 3 or 5. Therefore, the x of the intersection is? Negative 4. Now you try y on your own to see if you're getting the idea. What did you get for y? 5. Therefore, the intersection is 5, negative 4, or negative 4, 5. All right, cool. Now, then there's going to be, once in a while, you'll get some, probably on a test, this will happen, where you're going to get a problem, and you think you know Cramer's rule, but all of a sudden, it feels like you broke Cramer. So, let's go with this guy. If I try Cramer's rule on this, then the denominator matrix, reading across, what's the denominator matrix? 3, negative 2, negative 6, 4, okay? In the numerator, what's the numerator matrix? 3, negative 2, because the x gets replaced, and negative 6, 4. That is true. Evaluate, and you get, in the numerator, 12 minus negative 12, nope, minus 12, which is 0. And in the denominator, you get 12 minus 12, which is 0. Ay, ay, ay. What the heck? Does that equal 1? Please say no. No. Okay? So what's going on here? There is no solution. Why? Okay, now there are two cases you'll get no solution. One is they are either the same line. This, if you were to look at this and put this in plain old solve for y-ish form, you would say negative 2y equals negative 3x plus 3. So that means y is 3 halves x minus 3 halves. If I put it in slope-intercept form, you follow? If I did the same here, it would be 4y equals 6x minus 6. Divide by 4, I get y equals 3 halves x minus 6 fourths. That's minus 3 halves. Those are the same lines. So if you're trying to find an intersection point between two lines that are exactly the same, well, of course, things are going to be bad. That says same line, not same time. Sorry, same line. Another case is the lines are parallel. If you try and find an intersection point between two lines that are parallel, obviously that's not going to happen either. So if you get a bogus solution, if you get no solution, investigate which of these is going on. Okay? Is it because the lines are the same or because the lines are parallel? If they're the same, then everything is the same. But if they're parallel, then only the slopes will be the same. Yeah? Okay, that is that. Would you, on this little guy, please do solve this system by Cramer's rule, and when you get it done, come to me and I will give you your problem set. I just want to make sure that you understand what the heck is going on.
You've already messed it up. I have no idea.
You do not have to, but I will say this, there will be multiple choices where you will have to know what's going on. So I would personally practice it if I were you. Actually, let me just type that. What do I want you to say? I'll think about it. Let's try my own. Got it. See what she thinks. For now, no solution will suffice, I guess. I guess I need to do this myself so I know if you're linked. Make sure you put it in the correct form first. Unfortunate. No, that won't do. Go right as a matrix, please. I should see matrices over matrices. Maybe 1/5. Sorry, I'm so slow. 2, 1, 14.
Oops.
Sorry, I'm so slow. Okay. That's not what I got. What did I do wrong?
Wait, that's what we got.
Oh, never mind.
I got 2 6.
You think so, huh? You got 6 or negative 6? It's a negative in the denominator. Okay, you're good.
Thank you.
Thank you. Thank you. Thank you. This should, what is this should be? It should be, this is negative 11. Oh, never mind. I should have a negative somewhere in this one. Yeah. The way you did this is fine, but you should get a negative. Look at your y.
That's weird.
Yeah. You could get, depending on which side you put stuff on, it could be. Thank you. Any labels on those x's and y's? X equals this, y equals that. We got it.
What?
This should be negative 6.
Oh, yeah, correct,
Negative
yeah, correct,
66.
right.
Okay. There you go.
Okay, I have no idea what I did wrong. Because that's like way off.
I agree. 70 minus 466. Positive. Yeah, we don't. So,
Negative 2. Oh, I know. I just missed
that equals 2.
I did. I got negative 2 though.
This should be reflected there. That should be minimum charge of 2. Your x's are incorrect. Alright, looks like your denominator is good.
I got negative.
It should be a negative 6. This is positive 66.
Oh, yeah. I know.
Alright. Hi. Okay, x equals check. That's why. I need 2 matrices, so this is, that's what the work should look like, basically like I thought. So that's what it should look like. Yep, good, good. Thank you.
Can I write it out this? Oh.
I can't remember where I went wrong.
Okay. Check. Alright, so you did your exercise. I agree with that. Oh no, yeah, I agree with that. That's why we're good. Okay. So this is the 1, we're good there. 1, I agree, the bottom is 11. Cool. This, x's get replaced. 1, we're good there. 14. See, that's cool. We're good. So this is the issue. So here on y, you leave the x's the same and replace the y's. So this should be, the x's will stay the same. It's the y that gets replaced.
That's what I did.
You put the 14 and 4 in x's place. The x column is the first column. The y column is the second column. So when you put 14 and 4 in place for y, it's got to be in the second column. That's why you're getting a 7 there, because you have it. So it's,
What's 4 minus 70?
right, so maybe 66.
Oh,
Okay? So when you put it in for y, it has to be in the second column. It can't be in the hi. Thank you. Hi. Thank you. Hi.
It's my day. My brain's not working today.
Why not?
I don't know, I'm really tired.
You good, thank you. Dude. Alright, now this is one. Have a good. We'll check it tomorrow's warm-up.
GTY.
Thank you.
Do it, Charlie.
Thank you.
I'll grab it.
Thank you. Alrighty. If you didn't get a homework, come get one. Even if you didn't get that warm-up or didn't get the whiteboard problem. Afterwards, after practice. If you didn't get one of these. I have extra copies. Anybody else? Thank you. Have a great day. Thank you. That's a fine backpack. Can you get anything in there?
I love it.
Thank you.
Thank you. Have a good day.
I like having my phone.
Not you. You're not Kramer's rule. Hang on, let me stop this recording.